Hello, welcome back. I'm John, old YouTuber. I got a small break and a little bit bread to eat. I made another Danish video I'm uploading. And I made the PDF document ready. And I did download some more. That's the GeForce 600. Then the GeForce 700 and 800M. That's a mobile computer. That's no GeForce 800, but GeForce 900, then the 1050. This is GeForce 1050. You got 1050, 1060, 1070, 1080. That's no 1090. Then you got this 16. Let's call this 1650, 1650, and 1660. Then they have a super like 1650 Ti Super. Then the GeForce 2000. They have 2070, 80, and 90. I think I'm not sure the 90, but the 3000 have they have a 50. No, they have a 50, 50, 60, 60. I'm not sure. I don't remember but the 3050. 60, 70, 80, 90, 50, 60, 70, 80, 90. So I got 5 and the same, but the 4050 and 60 you cannot buy as a graphic cards. But I saw it on the new Asus Strix gamer laptops, 13, the Intel Core 13 generation. I saw some GeForce 4000 and 50 and 60. But you cannot buy it into stationary computers yet, but you can do that in a few months, like a 4050. So next is 5000, 5000 and 6000, 7, 8000 and 9000. I don't know what they will call the 10,000, but of course they can call it GeForce 10,000. Then 10,000, 20, 30, 40, 50, 60, 70, 80, 9,000. No, 90,000. So, but let's read about it and have it ready. GeForce 600 and 700 and 800M. So let's read about it. So when I did move into this apartment, October 2012, so this graphic card, the GeForce 600, was out when I moved to here. Now we have the GeForce 4090 and GeForce 5000. We will have in Christmas maybe. The 5090 will be out before Christmas maybe.
GeForce 600 series. GeForce 600 series 690 GTX.jpg. GeForce GTX 690 released in 2012. The series flagship unit Yasida March 22, 2012. Codename GK10's architecture Kepler model GeForce series GeForce GT series. GeForce GTX series. Transistors 292M40nm, GF119, 585M40nm. GF108, 1.170B40nm, GF116, 1.950B40nm, GF114, 1.270B28nm, GK107, 1.020B28nm, GK208, 2.540B28nm, GK106, 3.540B28nm, GK104. Card Central Level 605. GT610. GT620. GT630. GT640. Mid-range X650. GTX 650T. GTX 650T Boost. GTX 660. High-end 660T. GTX 670. GTX 680. Enthusiast GTX 690. API support Direct 3D 12.0, feature level 11_0, 1, shader model 6.5 OpenGlow Pengle 3.0, A, OpenGlow Pengle 4.6 Vulkan 1.2, 2, Spurvista predecessor GeForce 500, Series successor GeForce 800M series, GeForce 700 series. Support status security updates until September 2024. The GeForce 600 series is a series of graphics processing units developed by Nvidia, first released in 2012. They served as the introduction of the Kepler architecture. Overview. Where the goal of the previous architecture, FEMI, was to increase raw performance, particularly for computing and tessellation, Nvidia's goal with the Kepler architecture was to increase performance per watt, while still striving for overall performance increases. 3. The primary way Nvidia achieved this goal was through the use of a unified clock. By abandoning the shader clock found in their previous GPU designs, efficiency is increased, even though it requires more cores to achieve similar levels of performance. This is not only because F cores are more power efficient, 2 Kepler cores using about 90% of the power of one FEMI core according to Nvidia's numbers, but also because the reduction in clock speed delivers a 50% reduction in power consumption in that area. 4. Kepler also introduced a new form of texture handling known as bindless textures. Previously, textures needed to be bound by the CPU to a particular slot in a fixed size table before the GPU could reference them. This led to 2 limitations. One was that because the table was fixed in size, there could only be as many textures in use at one time as could fit in this table, 128. The second was that the CPU was doing unnecessary work. It had to load each texture, and also bind each texture loaded in memory to a slot in the binding table. 3. With bindless textures, both limitations are removed. The GPU can access any texture loaded into memory, increasing the number of available textures and removing the performance penalty of binding. Finally, with Kepler, Nvidia was able to increase the memory clock to 6 GHz. To accomplish this, Nvidia needed to design an entirely new memory controller and bus. While still shy of the theoretical 7 GHz limitation of GDDR5, this is well above the 4 GHz speed of the memory controller for FEMI. 4. Kepler is named after the German mathematician, astronomer, and astrologer Johannes Kepler. Architecture. The GeForce 600 series contains products from both the older FEMI and newer Kepler generations of Nvidia GPUs. Kepler-based members of the 600 series add the following standard features to the GeForce family: PCI Express 3.0 interface, DisplayPort 1.2, HDMI 1.4 4K x 2K video output, Pure Video VP5 hardware video acceleration, up to 4K x 2K H.264 decode, hardware H.264 encoding acceleration block, VANC. Support for up to 4 independent 2D displays, or 3 stereoscopic forward/3D displays, NV Surround. Next Generation Streaming Multiprocessor, SMX, A new instruction scheduler. Bindless textures. CUDA compute capability 3.0. GPU boost. TXAA. Manufactured by TSMC on a 28nm process. Streaming multiprocessor architecture, SMX. The Kepler architecture employs a new streaming multiprocessor architecture called SMX. The SMX of the key method for Kepler's power efficiency, as the whole GPU uses a single core clock rather than the double pump shader clock. 4. The SMX usage of a single unified clock increases the GPU power efficiency due to the fact that 2 Kepler CUDA cores consume 90% power of one Fermi CUDA core. Consequently, the SMX needs additional processing units to execute a whole warp per cycle. Kepler also needed to increase raw GPU performance as to remain competitive. As a result, it doubled the CUDA cores from 16 to 32 per CUDA array, 3 CUDA cores array to 6 CUDA cores array, 1 load/store and 1 SFU group to 2 load/store and 2 SFU group. The GPU processing resources are also double. From 2 warp schedulers to 4 warp schedulers, 4 dispatch unit became 8 and the register file doubled to 64K entries as to increase performance. With the doubling of GPU processing units and resources increasing the usage of die spaces, the capability of the polymorph engine double but enhanced, making it capable of spurring out a polygon in 2 cycles instead of 4.5. With Kepler, Nvidia not only worked on power efficiency but also on area efficiency. Therefore, Nvidia opted to use 8 dedicated FP64 CUDA cores in ASMX as to save die space, while still GTX 690 cooling shroud removed, with dual Kepler DIs visible. Offering FP64 capabilities since all Kepler CUDA cores are not FP64 capable. With the improvement Nvidia made on Kepler, the results include an increase in GPU graphic performance while downplaying FP64 performance. A new instruction scheduler. Additional die areas are required by replacing the complex hardware scheduler with a simple software scheduler. With software scheduling, warps scheduling was moved to Nvidia's compiler, and as the GPU math pipeline now has a fixed latency, it now includes the utilization of instruction-level parallelism and superscalar execution in addition to thread-level parallelism. As instructions are statically scheduled, scheduling inside a warp becomes redundant since the latency of the math pipeline is already known. This resulted in an increase in the area space and power efficiency. 4. 6. 3. GPU boost. GPU boost is a new feature which is roughly analogous to turbo boosting of a CPU. The GPU is always guaranteed to run at a minimum clock speed, referred to as the base clock. This clock speed is set to the level which will ensure that the GPU stays within TDP specifications, even at maximum loads. 3. When loads are lower, however, there is room for the clock speed to be increased without exceeding the TDP. In these scenarios, GPU boost will gradually increase the clock speed in steps, until the GPU reaches a predefined power target, which is 170W by default. 4. By taking this approach, the GPU will ramp its clock up or down dynamically, so that it is providing the maximum amount of speed possible while remaining within TDP specifications. The power target, as well as the size of the clock increase steps that the GPU will take, are both adjustable via third-party utilities and provider means. Of overclocking Kepler-based cards. 3. Microsoft DirectX support. Both Fermi and Kepler-based cards support Direct 3D11. Both also support Direct 3D12, though not all features provided by the API. 7. 8. TXAA. Exclusive to Kepler GPUs, TXAA is a new anti-aliasing method from Nvidia that is designed for direct implementation into game engines. TXAA is based on the MSAA technique and custom resolve filters. Its design addresses a key problem in games known as shimmering or temporal aliasing. TXAA resolves that by smoothing out the scene in motion, making sure that any in-game scene is being cleared of any aliasing and shimmering. 9. NVENC. NVENC is Nvidia's SIP block that performs video encoding, in a way similar to Intel's QuickSync Video and AMD's VCE. NVENC is a power-efficient fixed-function pipeline that is able to take codecs, decode, preprocess, and encode H.264-based content. NVENC specification input formats are limited to H.264 output. But still, NVENC, through its limited format, can perform encoding in resolutions up to 4096 4096.10, like Intel's QuickSync. NVENC is currently exposed through a proprietary API, though Nvidia does have plans to provide NVENC usage through CUDA.10 new driver features. In the R300 drivers, released alongside the GTX 680, Nvidia introduced a new feature called Adaptive VSync. This feature is intended to combat the limitation of sync that, when the frame rate drops below 60 FPS, there is stuttering as the VSync rate is reduced to 30 FPS, then down to further factors of 60 if needed. However, when the frame rate is below 60 FPS, there is no need for VSync as the monitor will be able to display the frames as they are ready. To address this issue, while still maintaining the advantages of VSync with respect to screen tearing, Adaptive VSync can be turned on in the driver control panel. It will enable VSync if the frame rate is at or above 60 FPS, while disabling it if the frame rate lowers. Nvidia claims that this will result in a smoother overall display. 3. While the feature debuted alongside the GTX 680, this feature is available to users of older Nvidia cards who install the updated drivers. 3. Dynamic Super Resolution DSR was added to Fermi and Kepler GPUs with an October 2014 release of Nvidia drivers. This feature aims at increasing the quality of displayed picture by rendering the scenery at a higher and more detailed resolution, upscaling, and scaling it down to match the monitor's native solution, downsampling. 11. History. In September 2010, Nvidia first announced Kepler. 12. In early 2012, details of the first members of the 600 series parts emerged. These initial members were entry-level laptop GPUs sourced from the older Fermi architecture. On the 22nd of March 2012, Nvidia unveiled the 600 series GPU, the GTX 680 for desktop PCs and the GeForce GT 640M, GT 650M, and GTX 660M for notebook/laptop PCs. 13. 14. On the 29th of April 2012, the GTX 690 was announced as the first dual GPU Kepler product. 15. On the 10th of May 2012, the GTX 670 was officially announced. 16. On the 4th of June 2012, the GTX 680M was officially announced. 17. On the 16th of August 2012, the GTX 660T was officially announced. 18. On the 13th of September 2012, the GTX 660 and GTX 650 were officially announced. 19. On the 9th of October 2012, the GTX 650T was officially announced. 20. On the 26th of March 2013, The GTX 650T boost was officially announced. 21 products. GeForce 600 6XX series. Nvidia GeForce GTX 650 T1